going to the types of lasers, we'll see how a laser action takes place. There is a general phenomenon in every types of lasers. So that we'll have to be familiar with three types of laser actions: induced absorption, spontaneous emission, and stimulated emission. So we'll see one by one. The first one is induced absorption. Let's imagine, or let us see that there are two energy levels which are represented by the letters. E1 is the first energy level, E2 is the second or higher energy level than E1. Generally, E1 or the first energy level is known as the ground level. The ground level means it is the equilibrium state. That is, atoms are always accumulated in the ground level. You might be knowing what is an equilibrium state. That is, all atoms exist in equilibrium state unless an extra energy is offered. So that we'll see atoms that exist in the ground state. Now, induced absorption means the atoms in the ground state can be excited to the higher energy state. That is, it doesn't simply go to the high energy state, but we have to give some energy. This is staying in the ground level or the lower energy state because of insufficient energy. That is, the atom, assume that this is an atom, so that we are giving an energy of h nu. So what is h nu? H nu is the energy of the photon that we are providing externally. We know that this atom must have an energy of E2 minus E1, or the energy difference delta E is equal to E2 minus E1. How much energy should be needed? That is the energy difference between these two energy levels, and that is h nu. That is, h nu energy should be obtained for an atom in its ground level to be excited to the higher energy level. So externally we are providing a photon of energy h nu, and at the moment the atom absorbs that energy, it gets energy and it actually jumps to the excited state. And as soon as the atom absorbs, that is why it is called as absorption. As soon as the atom absorbs the energy of photon of energy h nu, it gets excited to the higher energy level E2. Now this is not here, it jumps to the higher energy level E2, and this process is called as induced absorption. Now we will see what is spontaneous emission. Spontaneous emission means we have excited the ground level atom to its excited level. Now we will see the atom in its higher energy state E2. Now the atom is in its higher energy state E2. As I already said in the beginning, the energy level E1 is known as ground state, and it is the most equilibrium state for an atom. That means the higher energy levels are non-equilibrium states. The higher energy level is having a very short lifetime of 10 raised to minus 8 seconds. So obviously, when an atom is in its higher energy state, in 10 raised to minus 8 seconds, it gets de-excited, or its stable state or equilibrium state has lost, and it should be returned to its equilibrium or ground state. Then in 10 raised to minus 8 second, the excited atoms releases, or it's jump down to its ground state or the equilibrium state by releasing an energy of photon of energy h nu, the reverse of induced absorption, and that is called as spontaneous emission. Here there is no need to give an extra energy for an atom to de-excite to its ground state, but in 10 raised to minus 8 seconds, it automatically, or after releasing an energy photon of energy h nu, it returns to its ground state or the equilibrium state. Now, the next process is, or the next type is stimulated emission. Stimulated emission means there's a short difference, that is, while an atom is in its excited state by induced absorption, obviously, in 10 raised to minus 8 seconds I have told that it can occur spontaneous emission. But all atoms before 10 raised to minus 8 seconds can be de-excited to its ground state. That means an atom in its higher energy state E2 can be given an extra photon of energy h nu. That is, already an atom absorbs a photon of energy h nu and get jumped into its excited state, and before getting de-excited we are giving another photon, that is the second photon. This is the second photon of same energy h nu to this atom, so that when it's de-excited, what will happen? We all know that it will not be staying in its high energy state as it is non-equilibrium state for a longer time, so that it gets de-excited. Then what happens? It is having two photons of each energy h nu. That is, one is the photon that is given to excite to its high energy level, and the second one is, that is, we have given from its excited state. That is, while this atom jumps to its ground state, it releases two photons of h nu energy h. Is that clear? So that the main three types of processes that is occurring in a laser action is induced absorption, spontaneous emission and stimulated emission. So you should be familiar with all these three processes, and laser action occurs using any of these three processes.